Hello students, so today is the second day on solving equations. So the question we're going to ask ourselves, what if the equation is already in log form, aka a logarithmic equation? How can we solve that? So what you're going to want to have on you, calculator, pen or pencil, and then your notes today as well. There's two types of log equations that you're going to see. There's one with logs on both sides and logs on one side, kind of like we had last time. So here's an example of logs on both sides. These are the simplest ones. So what you're going to want to think about is how to make things equal. So you're going to want to see, do you have like bases on your logs? I do, in fact. So what actually is cool, you can just set the insides equal to each other and solve. So you just need the logs to be the same. So that is always going to happen as long as you have logs on both sides and they're the same base. So let's solve here. So I'm going to add 7. 4x equals x plus 12. Subtract x, it looks like. So I get 3x equals 12. Divide by 3. X equals 4. And that checks out perfectly. Just in my mind, I did do a little quick check. You're going to get the same answer. So always kind of be careful with that. Always check your answers. Log on one side. Isolate the log and change it into exponential form. So kind of like when we had exponential only on one form, we changed it to log. We're going to go opposite of this. Notice how you can't get to this x right now because it's log base 10 of x. So you're going to want to go to exponential form because your log's alone. So it'd be 10 to the negative 2 equals x. Okay? 10 to the negative 2 is equal to 0.01. And it does check out. If you check that on a calculator, it will check out. Let's try this one. 7 plus log base 10 of x equals 4. So the very first thing I need to think of how to do is I need to get rid of this 7. I need to get log completely alone. So I'm going to subtract 7 from both sides. 4 minus 7, that's negative 3. So now, I can't get to that x. So we need to convert to the other form. So I'm going to go 10 to the negative 3 equals x. So x has to be equal to 0.001, roughly. And that one also checks out if you plug it into your calculator. What about a natural log? Don't be too worried about this. Same idea. So very first thing, let's get rid of this plus 3. So I'm going to add 3 to both sides. And we're going to be left with 2 times the natural log of x equals 5 plus 3, 8. Now, can't convert to exponential form yet. I still have this 2. So let's divide by 2 on both sides. We get 4 because 8 divided by 2 is 4. Now, gotta convert to exponential form. So this is technically log base e of x equals 4, right? Because remember, ln is just log base e. So you got e to the 4th equals x. So x has to be e to the 4th, which is 54.6. And this checks out perfectly as well. Let's try this one. So log base 3 of 3 times x equals 2. So very first thing, I can't separate this 3 and times x because they are inside parentheses. So I need to convert to exponential to be able to get rid of that 3. So we're going to go 3 to the 2nd equals 3x. Okay? 3 to the 2nd, that's 9. Divide by 3. 3 equals x. And that one does check out perfectly. If you check that one. Let's do this one. Log base 2 of x minus 6 equals 5. So I get 2 to the 5th equals x minus 6. Notice I didn't add 6 right away because it's inside the parentheses. If it would have been outside, I could have added it. However, when it's inside parentheses, you cannot. So now I got 2 to the 5th, that is 32. X minus 6. Gotta add 6 from both sides, it looks like. 32 plus 6, 38. X has to be 38. Not too bad, right? Basically, all we need to do is convert to exponential form. But here are the hard kind. Very first thing I notice, I have two logs on the same side with a plus symbol in the middle. I need to combine those. So you're going to use your properties of logs that we've been talking about. Now, when it was added, two logs were added together to condense, adding became multiplication, right? So we're going to have log base 4 of x times x plus 12. See how I made those two multiplication? Equals 3. This is technically log base 4 of x squared plus 12x. Just distribute that x in there. Still equals 3, right? So now we get to convert to exponential form. So I can't get to those x's. So it's going to be 4 to the third equals x squared plus 12x. 4 to the third, that is 64. How can I solve this particular problem? Let's subtract 64. Get everything to one side. So I'm going to get x squared plus 12x minus 64 equals 0. How can I solve this particular equation? It looks like I'm going to get two answers to this problem. You know what? That looks like it's perfect for factoring. So my AC, 1 times negative 64, so my AC is negative 64. Doing some math here. 16 and a negative 4 should give me that positive 12, right? So remember, A times C is negative 64. Question you had to ask yourself, what two numbers multiplied will give you negative 64, but add together to give you 12? So I got 16 and negative 4, so I'm going to rewrite here. Whoop, brought my x there. 4x minus 64 equals 0. Let's box this guy. There we go. We got x going this way, an x going that way, 16 going that way, and a negative 4 going that way. So you have x plus 16, x minus 4 equals 0. So x has to equal negative 16, or x can equal 4. Now notice, I need to check solutions. These are the ones that you're more likely to get inaccurate solutions. Here's the easiest way to make sure that it's not going to work. If you would plug these in, logs cannot have a negative number for their x in the inside. So if you notice, if I plug in a 4, I would have a positive inside for my x, right? If I plug in 4 here, I'm going to get 16. That does check out perfectly and it works. But this negative 16, so this 4 worked out, right? Negative 16. Notice how I would have put a negative 16 there, right? Try log of negative 16 over log of 4 quickly on your calculator. What? It doesn't work? It doesn't work. You can't have negatives in the log. It just doesn't work. So negative 16 is an extraneous solution. It does not work in your particular problem. So if you get a negative x, answer of a negative x, particularly like negative 16, plug it in, see if you still have a negative inside the log. If you do, it will not work. That is the quickest way. Save yourself some math and some very hard math, to be completely and brutally honest. So be careful, no negatives in the log.
And that's the end of this video. See you later, Sabers.